Hi guys, it's Mrs. Gerhart. So you may have heard that we're going back to the moon. You may have also heard that we're going to Mars. So which one of these is right? Well, technically, both of them are right. We've got to go back to the moon and learn how to do a few things there before we're able to successfully go on to Mars. So let's spend a few minutes and kind of look at what is currently going on with NASA and this quest to return to the moon and then on to Mars. So every time we get a new president elected, they go through and they have a series of directives that they pass down, and it lets the government and the people of the United States know what it is they want to do and what their priorities are going to be during their elected term. So in keeping with that, President Trump issued SPD-1, which is Space Policy Directive 1. And in it, he charged NASA with landing the first American woman and the next American man at the South Pole of the Moon by 2024, followed by a sustained presence on and around the Moon by 2028. And I'll get to what this means in a little bit. Guys, 2024, it's only 5 years away. So that's coming up really, really quickly. The other thing that SPD-1 was provide NASA all means necessary in order to ensure mission success. This is really big because it allowed NASA the opportunity to kind of harness and leverage the resources that they had, but it also ensured that they received enough funding in order to pursue this lofty goal. So then the question becomes, well, why are we going? We went to the moon 50 years ago. Isn't that moving backwards? And there's 4 major reasons that NASA identifies as to why we're going. The first is inspiration. So NASA continues to inspire us with feats of science and exploration the same way the Apollo astronauts did 50 years. And it is hopeful that returning to the moon and then moving forward to Mars, that NASA is able to demonstrate the power of a unified purpose. That when we come together, not as a country and not as individuals or organizations, but when we come together as humanity, that we're able to achieve incredible things. Second reason is science. So the moon is a treasure chest of science. The lunar samples that the Apollo astronauts returned with changed our understanding not just of the moon, but also of Earth and of our solar system. And that was less than 2,000 pounds. So we're hopeful that in returning to the moon, we can learn more about our own planet, but also how we got here, how our solar system developed, and what that may mean for our future. Exploration is the third one. And it's not just exploration for America. It's exploration for all of humanity. Exploration is really at the core of who we are as a species, our desire to learn and discover. Why do we climb the tallest mountain? Because it's there. Why do we dive to the deepest depths of the sea? Because it's there. Why did we go to the moon in the 1960s? Because it's there. Why do we want to go on to Mars? Because it's there. So in a lot of ways, this is just fulfilling that human need to explore and to explore further. And this is the most logical push in terms of distance and space, which you've learned are incredibly vast. The last reason is a little bit more selfish. It's economy. We are not going to see a huge space economy probably in my lifetime, but it'll be developing in yours, and it will most definitely affect your children. And we are hopeful that in building a space economy, we can use mining and tourism and scientific research to fuel and empower our future generations. So what's different we went to the moon in the 1960s, but why are we going back? What is different now versus the 1960s, 50 years later? Well, this time we are going to stay. The Apollo missions lasted anywhere from a few hours to a few days on the moon, whereas this time we're really talking about having a long-term presence in the order of weeks and then followed by months and probably even years. And that's where a lot of the research on the International Space Station has been coming from as well. What are the effects on the human body of long-term space exposure? Space Policy Directive 1 allows NASA to effectively organize government, commercial, and international efforts. This partnership with commercial space efforts is new. This is not something that we saw prior to the kind of dismantling of the space shuttle program. The commercialization of space is pushing our space exploration forward in terms of speed, but also in terms of what it is capable of and our ability to kind of farm out and say, okay, you are going to work on this component and you are going to work on this component and we're going to work on this component and we're going to reconvene and see what it is we have come up with in order to solve this problem. So it's moving things at a much faster pace than ever happened previously when NASA was just a government agency. Major changes. Using sustainable and reusable rockets and rocket parts. We're very familiar with that now, living this close to Cape Canaveral, especially with the SpaceX landings. The alliance between commercial and international partners. Remember, we got really good with our international partners with the building of the ISS. This is taking it a step further. We're not just building with other space agencies. Now we are looking to kind of leverage those commercial relationships. Use the moon to enable further exploration of the solar system, specifically Mars, and then prove out technologies needed to make landing on Mars possible. So the moon is about 250,000 miles away, 250,000 miles away. And while that seems like a lot, Mars is significantly further. So the trip to the moon has historically taken 2 to 3 days in the Apollo program, whereas a trip to Mars would take 7 to 8 months. Guys, we can survive on the moon without food and without water for 3 days. We could get a rescue mission up there. We can't survive on Mars for 7 or 8 months without food or without water, unless you learn how to grow potatoes. So there are certain things that we have to be able to do before we can safely go to Mars. So this is the program for returning to the moon. It's called Artemis. It's a really interesting name. Artemis is the goddess of the hunt. She's also the goddess of the moon. And she is Apollo's twin sister. So why did the astronauts in the early days of NASA choose Apollo as opposed to Artemis to go to the moon? Because Apollo is the god of the sun as opposed to of the moon. And it all comes down to the fact that Artemis was a girl and NASA was run by a bunch of men, and all of the astronauts were a bunch of men. And as everything in NASA does, the Artemis symbol has a lot of depth and reasoning behind it. So I'm actually going to read these to you. The A symbolizes an arrowhead from Artemis's quiver and represents launch. Remember, she's the goddess of the hunt. The tip of the A of Artemis points beyond the moon and signifies that our efforts at the moon are not the conclusion, but rather the preparation for all that lies beyond. The crescent of the earth at the bottom shows missions from humanity's perspective. From earth we go, back to earth all that we learn and develop will return. This crescent also visualizes Artemis's bow as the source from which all energy and effort is sent. The trajectory moves from left to right through the crossbar of the A, opposite that of Apollo. thus highlighting the distinct difference in our return to the moon. The trajectory is red to symbolize our path to Mars. The moon is our next destination and a stepping stone for Mars. It is the focus of all Artemis efforts. They go on to say, we go now to the moon, not as a destination, but as a proving ground for all the technology, science, and human exploration efforts that will be critical for missions to Mars. On the lunar surface, we will pursue water, ice, and other natural resources that will further enable deep space travel. From the moon, humanity will take the next giant leap to Mars. It's pretty cool, right? So how are we getting there? Well, we are going to get there in this doodad. This doodad is known as the Orion space capsule. It is being built primarily by Lockheed Martin. So this is one of those commercial partnerships between NASA and Lockheed Martin. And the Orion capsule has a couple of main parts that we're going to look at. There are only 2 of them in this image. So this is going to be the middle thing that we talk about on the next slide, and then this is going to be the last thing that we talk about. So this top piece is what's missing in that first image, and this is the launch abort system. Super cool. This was actually just tested this summer, July 2nd, I believe, July 2nd, 2019. And the launch abort system essentially enables astronauts to get out real quick if there is a problem at launch. So the launch abort system, or the LAS, can be activated within milliseconds. It has 3 solid propellant motors that can launch the astronauts away from the capsule up to 600 miles an hour. So 600 miles an hour in a couple of seconds. Yes, they're going to be pulling some G's. But NASA has a pretty strict bring 'em home alive policy, and this is what the launch abort system is all about. As you learn more about the Apollo missions, you'll see that this abort system really came about because of the loss of the Apollo 1 astronauts on the launch pad. This second part here is the crew module. And this will carry 4 crew members beyond the moon. There are just under 691 cubic feet that will be pressurized, but only 316 of those cubic feet will be habitable. So 316 cubic feet for 4 people. That means that the people you're going with, you better be real friendly with. And then this last part at the very bottom, this is the service module. And this is basically the engine, if you will. The service module will hold the in-space propulsion, because remember, it will be launched by a rocket. But once in space, this is how the astronauts will propel themselves. It is where the power and thermal controls will be held. And then it's also where the water and air is going to be held. So how are we launching it? We are going to launch it aboard this incredible technological feat. This is the SLS, or the Space Launch System. And it is going to be the most powerful rocket that we have ever created, even more powerful than the Apollo rocket. It will be 1 foot taller than the Saturn V rockets that launched Apollo, and yes, that is on purpose. Here is where the Orion will be. So you can see up at the very top here, this is the launch abort system. And then in the middle, but not really visualized here, this is where the crew module will be. And then this bottom part here is where the service module is. So here is Orion's pathway. We have completed these 3. And next year, 2020, I think that they are hoping for December 2020. Don't quote me on that, but I think it's December 2020. They are hoping to launch an unmanned mission. It will have the Orion capsule aboard it. The Orion capsule will go out to the moon and beyond the moon, and then return to Earth. And this is unmanned because we've got to make sure that Orion can do everything it's supposed to do and keep our crew safe. The second launch is supposed to be manned. It will probably take a crew of 3 or 4 to the moon. They will orbit the moon and then return home. And obviously what we are looking for here is, does Orion function with a crew aboard? The third mission, scheduled for December 2023 to 2024, is a potential landing mission, they're saying. I'm not quite sure how, because these pieces here that I'm going to talk about in just a few minutes, this is Gateway. Gateway has to be in place before we are able to get anybody down to the lunar surface. So I'm really not sure how Artemis 3 would be an actual landing mission. I think it is more likely that Artemis 4 is going to be our landing mission, and it is again scheduled hopefully for December 2024. Remember, SPD-1 said that they want the first American female and the next American male at the moon's south pole by 2024. And then the follow-up missions 5, 6, and I believe 7 and 8 have also been funded, would be launching at about once a year from 2025 on. So Gateway, which is what I just mentioned. What is Gateway? Well, Gateway is basically a small spaceship that's going to orbit around the moon for astronauts, as well as for science and technology demonstrations. So even in Apollo, we had to leave one astronaut orbiting the moon while the other 2 got to go down and play on the moon's surface. And this is kind of the modern call to it. One of the differences, though, is that Gateway is going to be permanent. So you can kind of think of it as a very small scale International Space Station, but instead of orbiting Earth, it will be orbiting the moon. Gateway is going to be located about 250,000 miles from Earth, so it will enable access to really study deep space. The ISS orbits at about 250 miles above Earth's surface, so it's still considered low Earth orbit, LEO, low Earth orbit. And although we've learned significant things from the International Space Station, we've really never had this opportunity to study true deep space. So the Gateway picture that you're looking at here, this is the Orion capsule. The Orion capsule would dock here with Gateway. This is Gateway. And then this piece here, this would be what actually goes down to the lunar surface. So why Gateway is so essential for a 2024 landing. We've got to have the minimal systems in place in order for there to be astronauts that go to the moon. So here is Gateway Phase 1. And then here is the lunar landing component. And then here is Orion. So let's look at this. We've got to have this in place before we can do anything. We've got to have this in place because it is the docking system for both the Orion crew capsule as well as the lunar lander. If we don't have this, then we've got nowhere to transfer astronauts from the Orion capsule to the lunar lander, or back and forth. So the lunar lander is hopefully going to be recycled and reused, whereas they were not previously in the Apollo missions. The Orion capsule is going to kind of be a ferry, if you will, from Earth to the moon. And it's really the gateway, not the moon itself. And then back again. So this is how we will get our astronauts to the moon orbit, but then this is how we will actually get them down to the moon's surface. And I think one of the key things here with Gateway is that it's going to establish the U.S. in a leadership role around the moon. Because yes, we're saying we welcome commercial and international partnerships, but we still want to take that leadership role. We want to have the final say on things. So here is the path to the lunar surface by 2024. So you can see Artemis 1. This is unmanned. So yes, it's a human spacecraft, but it's not manned. This would be unmanned. Artemis 2 is manned. You can see that we have some, we have some other kind of interim things that we need to get in place. So obviously we need this crew module delivered to Gateway. And then this is where they're saying that we could potentially have a crewed mission that meets up with Gateway and makes it down to the lunar surface. From what I have heard, and I've attended several conferences at this point, they really think that it's more likely to be Artemis 4. Artemis 3 would be the absolute earliest that anything could happen. So these are also about to start happening, and these are really cool. So if you think back to The Martian, remember the fact that Mark Watney had to get over to Schiaparelli Crater because the Ares 4 cargo had already landed? Well, that's what we're going to start doing with the moon. We're going to remotely land lunar payloads through some of our commercial partners before we actually put man and woman back on the moon. And then the goal is to hopefully have an extended presence on the moon and around the moon using Gateway by 2028. So that's it. Lots of exciting things happening. I know that we'll be hearing about them in both the national and the local news. So keep an eye out, keep an ear out. You are living in an incredible time for exploration in our solar system and in general. And you are living in an amazing place to experience that firsthand. So go Florida.